Hello and welcome to our tutorial series, how to build an on-chain game on Solana. So what we're gonna build is similar to Twitch Plays Pokemon, which was something in the internet a few years ago. So what happened basically is a bunch of people play together Pokemon, and everyone writes the controls in the chat, and then a character moves on the screen. And we're gonna build the same thing on-chain on Solana. So we're gonna build a Anchor program, and then we build a Unity client for that. And the idea is that you have some controls under the game, like move left, right, up, down, spawn a chest, or spawn an enemy. And then the players can walk around, and who collects the chest gets a reward. And yeah, and the chest will be filled up with some fees that users use to move or spawn or kill enemies. And we're gonna build the whole thing in Anchor. That's what we're gonna do today in the Solana Playground, which is an awesome little tool which lets you directly in the browser build and deploy your Anchor programs. And if you're lucky and you watch this video next week, then the Tiny Adventure tutorial will already be there. But what we're gonna do today is basically build this tiny adventure from the beginning to the end. And yeah, if you want, you can, next week, you can just click on the tiny adventure. I submitted it to the GitHub repository from Playgrounds, and there you will also have some instructions on how to do that. But today we're gonna start a new project. So for that, you just click here on the little plus icon, and we're gonna call it Tiny Adventure. Click Anchor and create. And now we already have our program here. So now you can see here on the left 3 files. The first one is the Rust program. This is basically the on-chain program. The second one is the client. This is where we will interact with the game. And the last one is the tests, where you can easily write test to test your program, basically. In the example, there will be tests. Today, we're not gonna write tests, but we build a client instead. So I will quickly explain you the project. And first, we're gonna build it. So just type build in the bottom. It's like super easy. Now you can see it already created this little address here. And we can already, we can't look on chain yet if it's there, but we need to deploy it first. And for that, here on the bottom left, you click this little button to connect your wallet. And then you will need to get some Sol. So you just type Solana airdrop 2, which gives you 2 Solana. And if this fails, then you should change your endpoint to DevNet Alchemy. That one works really well. And now we can deploy it already, which will now deploy this program, this very simple program example, to Solana DevNet. Be right back. So you will notice that this costs some Sol, and around 3.5 Sol, I think. And this is the fee you have to pay to save this program on chain. And now we're gonna look at the program. So we just go to the explorer.solana.com on DevNet, and we type in the program ID. And then we can see here that it's an unverified Anchor program, and that it has a balance of 0.001 Sol, and that the executable data is saved in this address here. So what the deploy does, it takes the data, basically the bytecode, and takes one transaction at a time. It pushes them into this account. And here you can see it costs 0.5 Sol to be rent exempt, so that it basically stays on chain forever. And here you can see the upgrade authority is ourselves, so the wallet that we created in the playground, and the data size is quite big actually. If you also watched the video about my Rust tutorial, it was way smaller. So Anchor comes apparently with some fluffy data around it. I didn't really look into how much it is, but apparently it's definitely more expensive. But it also comes with some nice improvements, and some things are easier, some things may be harder, but we're gonna write this one in Anchor. So now we're gonna run the test. What this does, it creates a new key pair, and then it creates some data, and then it calls playground PG program methods initialize with the data 42. Then we pass in 3 accounts that I will show you in the Rust program in a second. And then the signer will be also this account here. And then we .rpc sends it to an RPC node, and then it will be on chain. The connection confirm transaction confirms that the transaction went through, and then afterwards we fetch the data. So PG program account, new account, fetch with the public key that we created here will get us the data back, and then we assert that the data is on chain is equal to the data that we put in here. And as we can see, it's 42. So if we look at this transaction hash on the Explorer, we can see here on the bottom that it changed the data to 42. So you deployed your first Solana program. How awesome is that? The instructions are unknown program. That's the one that we just deployed. And create account. And it's 16 bytes, which is one account plus one unsigned U3064. So that one also has 8 bytes. Okay, so now we looked at the test. Now we're gonna look at the program. So basically what we did in the test is we called initialize from the methods of the program. So if we go to the program, we can see here we have one function which is called initialize. What a surprise. And then we're gonna take the context, which is the initialize context, which you can see down here. It has one new account with a space of 8 plus 8. 8 is one account, and 8 is one U64 data. Then we have the signer, which is our wallet, and we also need to pass in the system program because we need the system program to create a new account. And for that, we need to pass it in because in Solana, you always need to put all the addresses that you want to interact with. You need to pass into the transactions. And then what it does here, it takes the context, and then from the context, it takes the accounts, then it takes the new account, and then it takes the data from that and replaces this with the data that we put in, the U64. And the data of this account is this one, the new account data. So that's basically already it. And now we're gonna build our little game around it. So for that, we're gonna go into the client, and we're gonna copy from the test all this data here, basically until here. And we just remove this here. You can run this by typing run. And yeah, you can see it says my address and the balance, but we don't need that. So we run this now again, and it will do basically the same thing as in the test, but now we directly run it in the client. And as you can see, here's the transaction, and the on-chain data is 42. The problem with this example is that we always create a new account, so we can't access this later anymore. And for our game, what we want is we want that everyone can interact with the same account. So the same account data, so that we can use the player to move him around. And to do that, we need the account to be owned not by ourselves, but by the program. And for that, we're gonna use a PDA, a program-derived address. And to find out what that is, I would recommend you to read a bit in the Anchor cookbook about PDAs, and then look at the JavaScript API. I will put the links in the comments. But what we're gonna do now is we will just search here for find program address, and then we just copy this code here and replace our account with this find program address. And here we need to put in the address of our program address key. That one we get by pg.program ID. So now we have the program ID. And then we put in a seed. We're gonna put level 1. What this does is basically, if you imagine like a database, and you have a table where the program ID is, and now whenever we add a seed, we just go up or down basically another entry in the database. And maybe that's the easiest way to understand it. And so, for example, if we now go level 1, 2, 3, 4, we could have 4 different accounts for that. What we could also do is we could additionally also put the account of the current player in, and then we would have 1 instance per player. So we could also put the PG public key in here also as a seed, for example, and then we would have multiple instances of the level. But what we want is this here. The problem is if we run this, so if I do console log of this account that we just got, this PDA, so I'm just gonna write account and then we're gonna print it. So if I run this now, you can see that something is not assigned. So we need to put this in here. And for the signer, we're gonna use pg wallet.keyPair. So the signer will now be our wallet. That's the one that we defined here on the bottom left. And the account that we're gonna create will be this PDA here. Be very careful to not put your wallet address here in the new account, otherwise you transfer your ownership to the program and then you can't use the wallet anymore, which happened to me earlier. It's a bit unfortunate. But now, if I run this, we have a signature verification error. And this is because the Rust program here, it expects an account and not something with seeds. So we need to put in the seeds here as well. So we're gonna put the seed, I think it's something with B and then a string and then level 1. But if you're not sure about that, you can always look up the documentation, and then I think you can see it here, for example, in the cookbook. Here the seeds, for example, for this one is B user stats and a user key, but we only want a string. So this should be correct. So now I'm gonna build this again, and then I'm gonna deploy it again, and then we're gonna run again, and then it should probably work. See you in a second. Now you can see that I had a bunch of errors here, and it actually told me that I also need, if I put a seed, I also need to put a bump. That's actually the thing I wanted to show you earlier here. When I run this, you can see that the account here, there is an account address, comma, 255. So basically what it does, if you have a program address and you put a seed to get the PDA, like I said earlier, you move up and down, and an additional to bump it off the cryptographic curve, you also get a bump which goes from 0 to 255, and you also need to pass this into the Anchor program. But Anchor does this automatically, so all you need to do is to add here bump, comma as well. And here, of course, we don't want to get the address, comma, the bump, but what we want is we want the public key and the bump. And now if we print this, then you will see that this will probably work. So I'm gonna run again, cannot read property of defined of undefined. Let me see. Okay, that was here at the bottom. Of course, here we also need to put this public key, and then it should hopefully work. Still not. So now I'm running it again, and now we can see the on-chain data is 42. The problem with that is, now if I run it again, we will get an error. Error processing instruction 0, custom program error 0x0. Why is that, you might ask? The problem is that we are initializing the same account again with the same public key. So this account is already in use. The error message is pretty shit. It says 0.x0x0, but that's what it is. So what we need to do now is Actually nothing, because actually it's okay. We only want to initialize the account once, and then the idea is now that we move the character from left to right and back. So for that we're gonna now write finally the game. So we're first gonna change the Rust program a little bit. So what we want is we don't want this to be called new account. We want it to be called game data account. And we don't need an U64, but we just need a U8 because we just want a one-dimensional path basically, and U8 is more than enough for that. So, and if we use a U8 now, we also don't need that much space anymore. So we just need the space of 8 for an account plus 1 for a U8, which is 1 byte. Then this will not be a new account anymore, but it will be our game data account. And this here we also call new game data account. So, and now here on the top, we gonna take accounts dot new game data account dot data, and the data that we pass in will also be a U8. The context will stay the same. It's initialized. This comment here we can delete because it's not correct anymore now. And yeah, okay, this is basically what we need for our data. So the position of our character will be the position in this U8 basically. So we just count it up until 3, and when he's at 3, he will be super happy that that he managed to do it. So here we just write journey begins, and then we duplicate this and write player position is at the start, and here we don't need the data. So, and now we need new functions. So we want the function to move left and we want the function to move right. For that we're just gonna copy the first function and we're gonna call it move right. And the context will not be initialized, but it will be move right. And we don't need data for that because we will just increase the number. And on move left, we will do basically the opposite. So we write here move left. And what we do is we take the data and say here move right is +1 and move left will be -1. Problem is, since this is an unsigned data, we can only do this if the data is greater than 0. So if this is greater 0, we're gonna decrease the number by 1. And if we move to the right, we want if the data is smaller than 3. So we're gonna be able to do 3 steps. So if the data is smaller than 3, we will be increasing the number, and otherwise we will write we reached the end or something like this. You made it. That's right, you made it. You made it. Woohoo! And we're gonna also write our little text here. Dot, 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 and then there will be a happy guy. And for that we don't need the data as well. Here we also don't need the data. Yeah, this is looking good. I think what we're gonna do is we're gonna write ourselves a function which prints the data. First we can say here if it is null, we're gonna write something like you're back at the start or something like this. You are back at the start. This message will be shown in the transaction logs that we know. Don't think we need that. All right. So I quickly turned this around here. So that if the data is 3, then you made it. And otherwise, it's if it's not yet 3, we're gonna increase the data. And then I wrote this little function here, print player position, which is just like below the other functions. Yeah, we put in the player position, and then it prints here. If it's 0, we are at the start. If it's 1, we are in the middle. If it's 2, we are almost at the end. And if it's 3, then we made it. And what we of course need to do is in every anchor function, we need to return OK. OK is basically the result. The result is empty. So maybe we just try build it. There will probably be a bunch of errors. And the nice thing is the errors are pretty good. So you can just go through the errors. There are a lot of errors actually. This is an unknown character, it says. So for that we need to add another one. Then it says data. Argument is never used. A journey begins. That makes sense. Then the next one is could not find client accounts move right to create root. This is also true because we didn't create this derive account struct yet. So we need one for move right and we need one for move left. So we're gonna make them empty first and move left. And all we need here is basically one account, which will be this one. It's the game data account. And here in the game data account, we're going to call this player position. So now we have move left, move right with game data account. And this is the context that we're going to use in the move. Oh, I should probably use the move left here. So we have move right with the move right context, and we have move left with the move left context. Theoretically, we could probably use the same context, but maybe we want to change something later. So it's more clear like this, I would say. Okay, let's build again. So I think the errors are getting less slowly. New game data. New game data account data doesn't exist. Of course, they don't exist anymore because this one is called game data account and this will be player position. Player position. Game data account, player position here, game data account, player position, and here as well. And where else did I forget it? Here as well. Okay, let's try again. Build. Almost there. Game data account, player position. A field with similar name exists. New game data account. Okay, line 11. Okay, here it's still new game data account because in initialize we create a new account. So that's why I called it new. So almost there, almost there. Could not compile. Program because of return type. Found unit. This error. Let me quickly figure this out. Okay, that one is, I think, because I put the print player function within the hello anchor program, and that needs to be outside. And then the hello anchor, we want to call tiny, how was it formatted for all lowercase? So we call it the same, tiny adventure. The nice thing, by the way, if you go in the client and you hover over the program, you can see the IDL here. So everything we put in the program, we can easily see also in the client, which is very nice because it creates an IDL, which is basically a representation of this in JSON. And this IDL we will later use in Unity. So we're going to pass it to a C# code with anchor converter. And then we can use it in Unity as well. So it will be very convenient. So let's remove these useless comments, and then we build again and see how much we have left. 2 warnings. Could not compile to previous errors. Okay, unnecessary parentheses. Yeah, apparently, actually, Anchor doesn't like parentheses, but I like them a lot. So I'm a bit annoyed by these warnings, but it's okay. So then we have an error, data, not found in scope. So, can't find data, because what we need to do is just -1, because we're not even passing in data anymore. And the same will be here, so we just do plus equal 1. So let's see. Now it should run. Yes. Okay, now we're gonna deploy it, and then we're gonna rewrite our client to be able to move left and right. Okay, that deployed. So now we're gonna write our client to move the character left and right. First of all, we need to change the data from 42 to 0, because otherwise we start at 42 and then we basically need to walk back forever. So we're gonna run this. A new game data account not provided. Okay, this needs to be now new game data account. How did we call it? New game data account. Okay. No, doesn't work. Why not run? Failed to send transaction. Transaction simulation failed. It's already in use. Yeah, okay, that's the same. I don't know why it shows it as an error. Maybe we need to reload. Sometimes after you deploy, the IDL isn't updated correctly. So, but yeah, this seems to work. And now the data is wrong, because this is a big integer, a big number. So we just, instead of doing that, we're just gonna put in 0. So that looks good. And then here we also need to write account dot game data account fetch. And here we need to put game data account to string. No, here we need to get the player position. Player position. Nope. It's not new account. So this is game data account actually. Okay. So this is looking good. Let's run. We should still get the error, because the account already exists. So what we're gonna do now is we're gonna start moving. So we comment out the initialize, and instead we're gonna write a move right transaction. So I just copy this here, and instead of initialize, we call move right. And instead of new game data account, we just put in game data account. And instead of signer, we put nothing. And system program, we also don't need. So let's run this. Actually, it looks like we do need this. Account discriminator mismatch. 8-byte discriminator did not match what was expected. So I think the problem is now that we created the account with a U64, and now we have a U8. So we need to fix that. Yeah, now we have another error. Account discriminator mismatch. Number 3 error. 8-byte discriminator did not match what was expected. And I guess it's because this account needs to be mutable, because we're gonna change it. So we need to put this account mute above it, because every account that you want to change, you need to pass in as mutable. So now we need to build again and then deploy again. While I'm deploying, I noticed that I have another warning here, that this function is never used. Like, the idea was, of course, to print the player position. So we're gonna put in the player position here, and we're gonna put it here, left and right. And now I think our deployment should be done. So deployment successful. So we run again and we still have the same error. So I looked the error up in the Solana Stack Exchange, and it seems which is amazing, by the way. And looks like the reason for this error is I was passing an account of a different type. So maybe we just ran into the problem that that we created the account earlier and now we changed the type, but it's the same account. So what we're just gonna try out is now we put a seed game level 1 and game level 2, and then see if that fixes the problem. Deploy is done. So now we're gonna run this thing again, and hopefully this time it will work. Oh, that looks way better already. Okay, so we have our logs. On-chain data is 0. Perfect. So now what we're gonna do is we comment out the initialize. In the example, I made it a bit nicer that it checks the account data first if it is there and then initializes it. But now what we're gonna do is we just go right from here. So we just call pg program methods move right accounts. We put in the data account and the wallet is our signer. Remove this and I will add some magic here on the bottom. So that is basically that we have the game game data account. So this will just print the position of the player a bit nicer. So now what we're gonna do is we're gonna move right. So we run. And now we should see here on the bottom that we are moving. So there's the game. We are at position 1. So now we run again. Now we should be at position 2. And if we run again, we should be able to solve the game. Like, how amazing is that? And there we are! Woohoo! Okay, now we look at this on-chain. So we put our wallet address in the Explorer. And here you can see a few seconds ago, we have these 3 transactions. And the first one says move right. The second one says move right. And the last one says move right. You have reached the end. Super. So yeah, that is basically already it for this little tutorial. Now we can also here move left, by the way. And if I run this, it will move back a little bit. Yeah, I hope this inspires you a little bit to build your own on-chain game, and I can't wait to see what you build. Maybe you can just send me your program ID, and I gotta use my own client to interact with it. And maybe if one of you sends me one, then I will use your program in the Unity example. So the next thing we're gonna do then in one of the next examples is we're gonna export the IDL. I think this can be done here somewhere. Here's the IDL. So we can export it and then we can look at it. And, oops, no, where did it go? Here, this is the IDL. And here you can just see a nice representation of all the functions we have. We have the initialize, we have the move left and the move right. And if we pass this IDL in Unity, we will also be able to call the same functions, move left and right. And then the goal later is that we will make probably a nicer grid that you can move up, down, left, right. Then we will create a PDA where you can spawn a chest. And the first person who collects this chest, so the last one that does the transaction that moves to the chest, will get the reward that is in the chest. And then we will probably also add monsters, so you can spawn a monster, and whenever the player moves, also the monster moves. And you can maybe also shoot. And yeah, I think this will be very exciting. And yeah, I hope to see you in the next video. And maybe subscribe to the channel, because if we have more than 100 subscribers, we can name our channel. So that would be really nice. See you next time.